Hi everyone, this is James Lee. Welcome to EEC 474 2013 winter term. I'm from Group 8. This term we have built a rescue robot which can retrieve two golf balls at the same time by searching their corresponding signals along the maze. And now I'm going to talk about how to build our chassis. There are many things you need to consider when building a chassis. The critical point of building a chassis is its flexibility and its weight. In order to fulfill these two ideas, we need to consider its shape and the materials we use to build the chassis. In addition, as the whole design, you also need to consider how the robot can catch the golf ball. For our group, we will catch the golf ball by hitting the beacon and allow the golf ball to fall into the ball catcher on the top of our chassis. After considering these points, we can start design our chassis. First is material. So there are many materials you can choose to build the chassis. There are wood, there are irons, there are also aluminums. So in order to make the chassis light, I used aluminum. Aluminum is light and thin, and it's also strong and bendable. However, there are also disadvantages of using aluminum. It's metal, so it's conductive. So when you put all your components on there, especially PCBs, you need to use conductive tape to tape the surface to avoiding the short circuiting. So some people also think they can use their PCB to build their chassis. I think it's a pretty smart idea, but be careful when you design it, because once it's done, you cannot change the positions of the components. So in my method, there are also many ways to change it. So second of all, we need to think about the shape and the layer designs. So as you can see here, this is our robot. I have designed it into an octagon shape and built it into 3 layers. The reason why I choose to build it into octagon shape is because we have to build our chassis to move along this 20 centimeter by 20 centimeter square maze. So we also need to consider it might need to be turned 180 degrees or even 360 degrees. So if you build it into a square, it might touching the wall once doing the turning. So in octagon shape, it gives us the maximum space without touching the walls on the side. And you can see we built our chassis in 3 layers. So at the very bottom, there are ultrasonic sensor in the front. There are 2 gear motors with 2 rubber wheels, which is 6 millimeters diameters, and there are 4 grade tracking sensor on the bottom. So we drilled a hole for those sensors. So each sensor will be located in the X, as you can see from this graph. It's just right at the corner of the black cross. So once the robot is off track, it can detect black and white, and it will adjust the robot will adjust itself back to the track. So from the second layer, as you can see, there are Arduinos and PCB for the H-bridge, and also XBs in the second layer. On the side, you can see there is a 9-volt batteries on the side, and at the back, we also mount 4 1.5 voltage batteries on the back. This is powered for the motors, and this is powered for the Arduino's Mega 2560. So on the top layer, we have homing signal sensors. So it has 2 sensors which can sense 2 different frequency for the 2 beacons. So 2 on each side, and there are 3 sides, as you can see. So we can detect signals from any directions. And on the very top, this is the ball catcher. So when the robots hit the beacon, and the golf ball will just fall into the ball catcher. And in the ball catcher, we have another ultrasonic sensor. This ultrasonic sensor can sense we are at the direction of right underneath the beacon, so it will be stopped and very stabilized and waits the golf ball to fall in. So this is how we build our chases. Thank you for watching.